Hello my viewers, hope you have a wonderful day. I remain my humble nomenclature, ATD syntax homogeneity. Please do not forget to subscribe, like and share on my YouTube channel. So today we are going to talk about elasticity. Okay, from the word elasticity, what does it mean to you? Like, what did you understand by elasticity? The word elasticity is a phenomenon, okay, whereby an elastic material is tensed or stretched when a minimum or a unit amount of force is impressed. Okay, now let us give an example. You can consider a rubber. Okay, consider a rubber. A rubber is an elastic material. Why? Because it has the ability to regain its original shape after deformation or after the removal of force from it. If you try to consider a rubber, take a small unit of force. When you apply a force on a rubber, that rubber has a tendency to what? To extend or stretch as a result of the effect of that force on it. And after the force has been removed, the rubber returns back to its original shape or size after deformation. So, let us now see how we could apply some simple cases in this aspect of what? Elasticity. Okay? Now, do not forget again that elasticity is a phenomenon whereby an elastic material or object, okay, extend or stretched after force or load is removed and tends to regain its original shape after deformation. That is what elasticity is. So, Hooks, Dr. Hooks is a physicist, okay, who stated the relationship that exists between force and extension. What it means is that if you consider a rubber or a spiral spring, let's take a spiral because a spiral spring is an example of what? Of an elastic object. If you apply a load on a spiral spring, the spiral spring will cause an extension as a result of the effect of the what? Of the load. Are you with me? So the amount of load that is impressed on that elastic material gives, the lengthy extension depending on the magnitude or size of the what? Of the load. So the higher the force, the higher the extension. The lower the force impressed on the rubber, the smaller the extension the elastic object will give. Now let us take an example. Now let us suppose that this is a fixed point. This is a fixed point. Allow them in. This is a fixed point. And if you consider this elastic object that is attached to one end of the fixed point. Now, under normal circumstance, these objects have a 0 Newton force. Are you with me? It has a 0 Newton force. Why? Because no extension yet. Now, if we're not supposed to apply a small unit of force here, okay, we can deduce that a new extension is generated as a result of the impressed force on this material. Okay? Now, if we are to say this, do not forget that from Hooke's law states that provided the elastic limit of an elastic material is not exceeded, load or force impressed on the object is proportional to the extension. So if that should be the case, okay, that should be the case, it means force. The force on the string is proportional to the extension. Okay? Now, if we have to bring about the relationship between force and extension from Hooke's law, we can therefore say that F is equal to KE. Okay? This is an equation. But do not forget that K here represents the stiffness. The stiffness on the string. The stiffness in the elastic object. Then E is the what? Extension. While F is the applied force. F is the applied force. Are you there? Now, after understanding this, let us now deduce an expression for the extension in a simple case. Let us suppose that this is another fixed point. This is another fixed point, and a spiral spring is attached to one end of this fixed point. Naturally, the extension or the original length of this fixed point of this material that is sustained on the fixed point is LO when force has not been impressed. But if we apply a small unit of force here, we are going to have or develop a new length of that material. So the extension produced by this force is the difference in the length, the new length from the original length. So let us suppose this is equation 2. Okay? Now if we try to insert equation 2 into equation 1, we are going to have, put equation 2 into equation 1. So we are going to have F is equal to KE, that is from equation 1. So therefore, your F or the force applied is equal to K into extension the body gives is Ln minus Lo. So this will give us another vital expression for the force. Thank you for listening. In our next class, I'm going to give you the application of these formulas and how we could use this formula to solve varieties of questions in simple cases. Thank you. Please do not forget to subscribe, like, and share. Goodbye.